All right, so now we're moving on to slightly harder examples. In this case, we're going to be simplifying the expression root 27 times x to the fourth. So this is our first example where we're dealing with variables inside here. However, this is going to work exactly the same way as prior examples. We want to get factors inside the radical to be in clusters of 2. So here's how we go about dealing with this. First thing we want to note is that since we have two things being multiplied in here, we want to use the product rule for radicals. So that's going to give us square root of 27 times x to the fourth, just rewriting just so we can keep our work straight. Using the product rule, I have a root of two things multiplied, so that means I can have a product of the roots. So it gives us root 27 times root x to the fourth. Okay, so now we have this radical root 27 that we need to break down, so we need a factor tree. So we have 27. How does that break down? Well, it's divisible by 3 and 9. And 9 breaks down into 3 and 3. Notice that we're dealing with a square root here, so we are stuck with trying to group things into powers of 2. So here's here's a group of 2 3s, and we have the spare 3 floating here. So rewriting that first radical, so we have 3 squared times 3. And then we're going to carry along the thing that we weren't exactly dealing with immediately, just so that we can keep this equality true. Then we can use the product rule again because we have these two things being multiplied. So what does that buy us? That gives us square root of 3 squared times square root of 3 times square root of x to the fourth. Okay, now I have a square root and a square. Those cancel each other. This square root of 3 does not simplify any further, so we're stuck with what we have here. So the square root and the square cancel each other. I'm left with 3 times square root of 3. And then I haven't done anything with this x to the fourth thing yet, so that's going to get carried along. And then, okay, so we've broken down the number 27 using the techniques that we've developed in the previous several examples. But now how do we break this guy up? I have a square root and a fourth power. You could use exponent rules here to simplify this so it becomes x squared. However, let's try breaking this up into clusters of powers of 2. So this gives us 3 times root 3 times x squared times x squared. Okay, so if you note the exponent rules, so when we have the same base and two things being multiplied, you can add the exponents. So that gives us back what we started with. I just basically did that in reverse so I can get this into clusters of 2. In this case, I'm going to skip a step, and hopefully you guys will be okay with that. I'm just carrying that along for now. If I break this up using the product rule for radicals, I'll have a square root of x squared times a square root of x squared. Actually, yeah, I'm not going to skip a step. I think I'll just go with it. So I have square root of x squared times square root of x squared. Okay, the square cancels square root, the square cancels the square root. So we're left with 3 times radical 3 times x times x. But is that correct? We got to be very careful about this because now we have an even root with an even power. So that tells me that since this is a variable that we're dealing with, we have to use absolute value bars. Because if you take the square root of a square, that's going to guarantee that anything you plug in for x, either positive or negative, is always going to come out to be the positive version of the square, or the square root of the square. So try plugging in -1 and you get -1 squared, and so that gives you 1. And take the square root of 1, that gives you 1. So no matter what, you plug in a negative number, you're going to get the positive thing out. So when you have two absolute values being multiplied together, those absorb into one another. i.e., it's just going to be the absolute value of x times x, or if you like, 3 times root 3 of absolute value of x squared. Okay? At this point, you can drop the absolute value bars. That's perfectly fine, because you're squaring anything that you could possibly plug in for x. But at this point, you could basically call this problem complete. So if you found this video helpful, please like and subscribe. As always, it helps the YouTube algorithms and it helps us gain exposure. So thanks, and I'll see you in the next one.